Hello everyone, welcome back to Algebra Geometry 2. This is Unit 3 where we were talking about quadrilaterals, and we just got done talking about parallelograms, what they are, how we can show a quad as a parallelogram, and then we're going to be breaking down more special types of parallelograms. So today you're going to see, I'm going to go ahead and go down below here, the shapes that you're probably familiar with from your math experience in the past. And all three of these, rectangle, rhombus, and square, they all fall under the parallelogram family. So when you're looking, and we're about to define these here, all three of these, the first thing I'm going to write down on all of them is they are a parallelogram. It is a special parallelogram, and it's those special qualities that makes it a rectangle, a rhombus, or a square. So I just want to make sure I get that across. If we are still in parallelogram world today, we are just breaking it down into those familiar shapes and talking about why these are so widely used and what makes them so special. So jumping in with rectangle, it is a parallelogram with four congruent angles. Four congruent angles. Now, what I get from in my experiences in the past is people think that what makes a rectangle is it has right angles, which is awesome, don't get me wrong, but it's more because the angles are congruent. They're all the same. It just happens to be when we have a quadrilateral that there's 360 degrees, divide that by 4, and it happens to be 90. So yes, we have four right angles, but the big thing here is to think this is an equiangular parallelogram. The equiangular, meaning of course equal angles. I almost forgot how to spell parallelogram. So that's going to be important because when we talk about rhombus, I see a little bit more of a struggle of describing what a rhombus is. Please don't say slanty square. That's something we might say when we first get introduced to it in elementary school. But it's actually really simple. If you think of a rectangle as a parallelogram with four congruent angles, notice I'm starting the same way here. Rhombus is a parallelogram with four congruent sides. That is it. So when we look at rectangle, four equal angles. Rhombus, you'll see there's four equal sides, the same number of tick marks on either one. I'm going to highlight those angles too. So this would be called, instead of an equiangular parallelogram, this would be called an equilateral parallelogram. So what you'll see, and now that I'm going to bring these two in, and I'm going to talk about square here in a second, is that these rectangles and rhombuses, they have the original properties of a parallelogram. Opposite sides will be equal. Opposite angles will be equal. Diagonals will bisect each other. All those really nice things, but just on top of that, we have for a rectangle four congruent angles and for a rhombus four congruent sides. And with that, we're going to talk about more properties today that go with it, but I just want to make sure it's a parallelogram, and here's that extra little bit that makes it special. Probably the most structured and most special, I guess, is the square. So again, it is a parallelogram. And I'm sure you guys just know what's coming here. It's a parallelogram with four congruent, you knew that was how it was going to start. It's four congruent sides and angles. So we still have the congruent. What makes it special is it's got both. It is at the same time, it is a square, so it is a rhombus and a rectangle, both simultaneously. So we would say this is a regular parallelogram because regular means all the sides and all the angles are equal. So when I look at this, not only do I have the properties of a rectangle here, but I also have the properties of a rhombus. So a square is simply a rhombus and a rectangle at the same time. So we're going to move forward with these notes, and we're going to be talking a little bit more in detail about each shape that we just introduced. The first one up is a rhombus. Now, not only do they have four congruent sides, but with that, and kind of like when we construct it, we get some other special things. A parallelogram is a rhombus if and only if its diagonals are perpendicular, and I'll spell that out for you too, perpendicular. Now, what it means to be perpendicular is that these diagonals will form a right angle. It'll be 90 degrees. I'll even highlight it for you. Perpendicular, those diagonals will make 90-degree angle. So this is a rhombus if and only if AC, the diagonal AC, is perpendicular to BD. So that's one thing that comes with the rhombus, is that the diagonals are perpendicular. There's another thing that happens with the angles, actually, is a parallelogram is a rhombus if and only if the diagonals bisect the pair of opposite angles. So what you're seeing here is these diagonals come in and cut these angles in half. So I'm just highlighting them right now. But every angle gets cut in half. So ABCD is a rhombus if and only if AC bisects angle DAB and angle BCD. And then also the other one's bisecting. So BD is bisecting angle ABC and angle ADC. So what this is going to tell us, and here's just a little example, and I will erase this, is if I were to look at this top angle up here, and I told you, you know what, the whole thing of this is 80 degrees. Well, you would know that this would have to be 40, and this would have to be 40, because it is a rhombus, and a rhombus will cut that 80 degrees in half. So that's what it means when it says diagonals bisect opposite angles. All right, and now we're going to move on to rectangle. Rectangle, it also has something interesting about its diagonals. It's a rectangle if the diagonals are congruent. So notice here, the big thing is not only are they cutting each other in half, but all of these are going to be the same, because here when it's being cut in half, well, the whole AC and the whole BD started congruent. So when I cut it in half, I got those there. So that only happens in a rectangle, just like these top two only happen in a rhombus. And what we're going to use this here now is try to, you know, what do I say? We're going to try to classify, I guess is a good word, and that's actually what it says right here, classify the parallelogram, but we're going to deduce from the given information, and I like to start with the most broad and try to get to the most specific. So I would like you to pause this if you would, and then see if you can figure out, given that each one is a parallelogram. So we're starting with a parallelogram, and on part A, what you need to do is decide, is this a rectangle? Then after that, yes or no, decide, is this a rhombus? And then we're going to go from there. So for the first one, I'm going to say, is this a rectangle? Now when looking here, the only extra piece, because yes, I do have diagonals that bisect each other, but that's just a parallelogram. I have this extra piece, which is the diagonals are perpendicular. That is not a part of a rectangle. That is actually a part of a rhombus. And because I can't say anything about it being a rectangle, that is where we're going to stop. It's just a rhombus. B is a little bit interesting because it's a parallelogram. So remember, if I have this side here with one tick mark, parallelograms have congruent opposite sides, so I can mark that one. Same with this guy down here, I'm going to have this one. And looking at this picture, I got 4 congruent sides, a parallelogram with 4 congruent sides. That also is a rhombus. There's nothing for me to say that this is a rectangle, so we just get to stop there. All right. Part C here, they give me this right angle. Because it's a parallelogram, I know that opposite angles are equal, so this would be 90 degrees. And because it's a parallelogram, I know that consecutive angles have to be supplementary. So if those are 90, well, then this angle has to be 90, and this angle has to be 90 as well. Friends, this is a rectangle. This is a parallelogram with 4 equal angles. They're all right angles. And there's nothing I can say here to make it a rhombus, so that is about it. Now this next one is officially the fun one, because when I take a look at what I got here, I can mark more information. So I got 1 tick mark, I go to its opposite side, boom. I got 1 tick mark, I go to its opposite side, boom. And then I bring in this angle. Its opposite angle has to be the same, so it's 90 degrees. And then for the same reason, consecutive angles as last time, these would have to be 90. Now take a look what we got here. I've got 4 congruent angles. I've got 4 congruent sides. This is a square. It is basically what gave it away. It's a rhombus and it's a rectangle. If you ever have a shape that's both a rhombus and a rectangle, that means it's going to be a square. All right, E. E, I have diagonals bisecting each other, but look, they're all the same. So these diagonals are congruent, so that would be a rectangle, and that is about all the information we have. And this last one here is another fun one. So for the same reason, this is a rectangle because all the diagonals are congruent. And in that middle, we have the perpendicular relationship, so it's a rhombus. And remember what I told you, if we have rectangle and a rhombus, our final answer will be it is a square. So, all right, there's a little bit of practice of classifying these special parallelograms. Now we're going to get a little bit into solving. So we're going to classify the special quadrilateral, then we're going to find the values of x and y. So first doing what we just did, and I notice right off the bat all the sides are equal, and I notice all the sides, or excuse me, all the angles are equal. So this, for number one, first of all, it is a square. So part one done, which is classify the special quadrilateral. Now we need to find the values of x and y. And I'm seeing x here. Well, x is 3x, and 5x minus 4 is here. And those sides have to be equal. So let's just do that. We'll say 5x minus 4 has to equal 3x. And from here, we will solve. I'm actually going to take away the 5x. Get my x's on one side, so those will cancel. Bring down the negative 4 equals negative 2. And then we'll divide by negative 2. Cancel those out. And so x equals 2. So boom, we got this one here. We got x. And let's figure out where y is. Y is, okay, I'm seeing it's up here. I'm seeing it over here. They're also equal sides. So we'll just do 5y plus 1 equals 2y plus 4. Because it's a square, these sides have to be equal. So I'm going to take away 2y. Take away that. So I got 3y plus 1 equals 4. Take away 1 now. We got 3y equals 3. Divide by 3. I'm running out of room. That's okay. I will say y equals 1. So we had a square. I set those sides, those corresponding sides, what I needed equal to each other, and I was able to get x, and I was able to get y. All right, moving on. So the same instructions here. So let's take a look at what we got. I'm seeing these sides congruent, which would make it a rhombus, and I don't see anything else. So it looks like we're stuck here with just, it's a rhombus, which I know all the sides are equal. And then we'll talk about the angles here in a second, but all the sides are equal. So if I'm looking at these two, their two sides, again, they got to be equal. So 6y minus 5 equals 3y plus 7. I'm going to take away 3y to start. So we got 3y minus 5 equals 7. I'm going to add 5. So 3y equals 12, and then divide by 3, and we got y equals 4. So y done. Let's find x. So I see x here, and I see that it has a consecutive angle of 127. Now remember, this is a parallelogram. So these, it's a rhombus, which is a special parallelogram. So these angles, these consecutive angles, have to add up to equal 180 degrees. So 2x minus 1 plus 127 has to equal 180. And that's the equation we can use to solve for x. So I'm seeing some like terms here. So I'm going to do that. 2x plus 126 equals 180. Then I'm going to take away 126 from both sides to get 2x equals, what would that be, 54? And then divide by 2, and we get x equals 27. Big X value, but that's okay. So there we go, rhombus, and then we had the x and the y. And then here we are to our final example. It might help to draw a picture. I believe the one, I've seen this with a picture before. So it says the diagonals of rectangle WXYZ intersect at P. Given YXZ is 50 degrees and XZ equals 12, find the indicated measure. So if we don't have a picture, you know what I'm going to do? I'm just going to sketch one here. So I have a rectangle. It's named WXYZ, so we go in clockwise. X, W, X, Y, and Z. And what they told us, it's a rectangle. They say rectangle. So I'm going to put these right angles, these congruent for right angles. And then they talk about the diagonals here, so we should probably put in some diagonals as well. There we go. It's not the prettiest, but it'll work. Now, it is a rectangle here, so I know that these diagonals will be congruent also. So I'm going to add that, and then I'm going to switch over a different color. Let's put our given information. So they say YXZ is 50 degrees. So YXZ would be this small angle here, 50 degrees. And it says XZ equals 12. So the whole thing, let's see here, all the way. That was a good little sound effect there too, equals 12. And now let's take a look at what they want us to find. First one is WXZ. So WXZ would be this angle X here. I'm going to get rid of that now so we don't confuse us. If we're trying to find this angle, Well, I know the whole angle is 90 and the other part's 50, so I'm going to do just a little quick math. 90 minus 50 to get 40, so this one would be 40 degrees. WY. So WY is this big diagonal here. Now, I know the diagonals must be congruent, so if that one's 12, this other one must be 12 as well. PY. PY. Where did P go? Oh, they intersect at P. Let me add that. So let's say here in the middle, that's P. So if I want PY, well, the whole thing's 12, so this part has to be 6. Not too bad. And then WPX. WPX. So that one is this guy right here. Now to add this, remember we said that this was 40 degrees. And if we go around, what we're going to find out is that this would be 40 degrees as well because it's an isosceles triangle. So these, this angle and this angle be the same. And all triangles have to equal 180. So I'm looking at this whole triangle here. This one's a little bit tougher. So this triangle, I got two angles that are 40 degrees. I'm trying to find the third one. So I need to do 180 minus 40 minus 40. When we do this, we get 100 degrees. That one's a little bit of a tough one, probably tougher than you're going to see on your assignment. But yes, I believe that is it. So if you guys have any questions, please let me know. Today I'm going to go back all the way to the top about these three special shapes: rectangle, rhombus, and square. I will talk to you guys later. Have a great